We will be talking about the virtual labs. So we will be discussing how to conduct various experiments using free simulators. So the simulators you can download from the net free, and you will be able to perform various experiments related to basic electronics lab, digital electronics lab, advanced electronics lab, op-amp lab, and microcontroller lab using a simple laptop or PC and a stable internet connection. So you might have gone through the timetable. So we will be taking up basic lab on first day, basic electronics lab on first day, and on second day we will be conducting digital electronics lab or DCLD lab. On third day we'll be having advanced electronics lab. On fourth day we will be having op-amp lab or LIC lab, and last day is devoted to the hardware microcontroller, we can say, using Tinkercad simulator. So this course is being run in association with Touch Techno Delhi. So the most of the technical sessions will be conducted by Mr. Devinder Dhawan, who is technical manager at Touch Techno Delhi, and he is an expert in conducting experiments using these simulators. So I'm sure that these 5 days will be going to very useful for all the participants. So before we start with technical proceedings of the STC, so let me briefly introduce about our department, our NITR Chandigarh, to the participants who are joining first time, so that information might be useful for them. And all the participants who have done various STCs earlier, so they already know about the NITR. And after that introduction of NITR, so I would like to have a brief introduction of all the participants, and then we'll start with our technical proceedings. So it will take early 10 minutes more maybe. So let me share my screen. So dear participants, this slide shows various glimpses of NITR Chandigarh. Various facilities at NITR Chandigarh. Will slightly go through some of the facilities one by one. So NITR Chandigarh was established in 1967, and at that time it was started with the objective of technical teacher training, and not teacher targeted for polytechnic teachers. And in 2003, this institute was renamed as National Institute of Technical Teachers Training and Research, Chandigarh. And the domain of this institute then increased from only polytechnic to engineering college teachers as well as towards the research activity. And in 2012, so this institute was pioneer in conducting the ICT based short-term programs like we are conducting today. So training programs with the introduction of ICT started way back in 2012 by our present director, Professor S.S. Patnaik. So he started these ICT trainings by using the Google Hangouts and other free available tools at that time. As I have already told, so this was one of this institute was established in 1967, and it is one of the 4 national institutes established by Government of India at that time for addressing the concern of training the technical teachers. And it is now reckoned as a resource institute for the technical education system, providing services to its clientele covering faculty and staff of technical institutions, officials of directorate, boards of technical education, central and state government departments, industry, students from technical institutes, community, and trainees from overseas. So you can see from this paragraph that clientele of NITR Chandigarh is quite wide. So it is not devoted only to faculty or staff of institution. It also deals with the industry and different government and private departments as well as community in general. And the major activities of the NITR Chandigarh falls in these domains. First is educational and training program, like we are conducting today. And second major activity is curriculum development. Then next is instruction material development, and research and development, extension services, consultancy in technical education and technical areas. Also, this institute has been recognized as a research center by Punjab University Chandigarh in 2006, as well as by Punjab Technical University Jalandhar in 2005 for pursuing research work leading to the degree of PhD. So if we talk of PhD programs, then there are these three different types of PhD programs which are being offered. So QIP programs are offered for both polytechnic and engineering college teachers, and in addition to QIP PhD programs, so regular PhD is also offered under the affiliation with Punjab Technical University Jalandhar as well as Punjab University Chandigarh. Several ME programs are being offered by NITR Chandigarh. So these programs are offered in regular as well as modular mode. In electronics, we are offering ME in electronics and communication engineering in regular and modular mode, in addition to standard ECE ME. So from this session, we are also starting ECE ME in specialization with artificial intelligence. So these are the various programs run by electronics department. So other departments are also running ME programs in both modular as well as regular mode. So as I have just told that these are the various domains of NITR Chandigarh, where NITR Chandigarh actively explores different clientele system, serves a different clientele system. So educational and training programs, curriculum development, instruction material development, research and development, consultancy and extension services. So these are the major areas. And you can see from this slide, so in the last 3 years, NITR Chandigarh was actively involved in curriculum development. So these figures show the activities of the last 3 years. In 18-19, we designed 15 curriculum for different subjects and belonging to different trades. So there is a full-fledged curriculum development department named as CDC Curriculum Development Center, so which is taking lead in developing the curriculum for various engineering and polytechnic institutions along with the other departments. Instructional material development is also a major activity at NITR Chandigarh. So you can see that the number of video films and the print material generated during the last 3 years. So there are around 1900 video films generated in last 3 years and around 300 print materials generated. So in addition to online training or the short-term training programs conducted by NITR Chandigarh through NITR Chandigarh platform, so our faculty is also involved in conducting SWAM programs. So these are some of the programs which are being offered by the NITR faculty through the SWAM. So this is NITR Chandigarh is also National Resource Center, NRC in electronics and electrical communication, and under this also several programs are run by NITR Chandigarh through SWAM. The research and development is also a growing area at NITR Chandigarh. So several sponsored research projects has been taken by the faculty of the department in different areas during the last 3 years. So you can go see from these slides that the research and development projects involved to different domains. So research development is also resulting in a good number of publications. So faculty is involved in writing research papers also. So these figures show that the faculty is getting recognition at international and national level. Consultancy and extension services include various domains. So these are the major domains under consultancy and extension services which the NITR Chandigarh targets. So skill training, student skill training, recruitment, sport for lab development, in addition to sport for apex bodies like AICTE, UGC for their activities. NITR Chandigarh is also involved in the training of some foreign officials also. So NITR has a very good state-of-the-art facilities in labs, classrooms, as well as hostels. So I will not go through the facilities of other departments. So briefly, I will show you what we are having in ECE. So ECE has the very latest equipment and the state-of-the-art softwares for for different subjects. So we have a well-established communication lab, VLSI lab, TSP and soft computing lab, embedded system lab. We have very good antenna lab, which has facilities up to 20 gigahertz. In addition to this, we also have research lab for the PhD scholars. And ECE department is involved in training in different subjects related to the ECE domain. So these are the major areas where we also provide long-term training in addition to the short-term courses. So the advanced TSP, 3G and 4G technologies, VLSI design, antenna design, and FPGA. So these are the major areas where training is provided by NITR Chandigarh. So this is a common facility, ETV, Education Television Center. So NITR has very good studio for recording of the video lectures, video films. And in addition to main studio, so we are also having a number of small studios which are named like Golden Jubilee Hall or something like that. So we have multiple facilities where we can record the lectures, or we can conduct programs through ICT mode through those centers also. So hostel facilities are also very good at NITR Chandigarh. So we have many different hostels, so different hostels for boys and girls, with having a good capacity for the residents. And we also have gyms here, so an open gym and as well as indoor gym facility. So we have 2 guest houses at NITR. So the guest house 2 is a recent one which has been developed recently, so which are also open for various visitors of the institute. So these are glimpses of the guest rooms of the guest houses. So NITR Chandigarh also has this particular YouTube channel, NITR Chandigarh Technology Enabled Learning NCTEL, which houses videos related to different programs run by the NITR Chandigarh. So you can see that during the last few years, this channel was very popular among the learners. So we can see the number of views. So this channel has more than 13 million views by the participants. So you can also subscribe to this channel for referring to the earlier recorded lectures of NITR Chandigarh activities. So with this brief introduction, I now going towards the start of the STC. So first of all, I would like to have brief introduction of the participants which are joining this participant, so that we know each other, because we are going to spend one full week together. So it will be better to deeply know each other. So just a minute, please.
So your mic is off.
So I will be naming participants one by one. So I request the participants to provide the brief introduction, like name, place of work, research area, and the expectation from this STC. So first, I am calling the participants Shri A.S. Kirthi Naini. You can unmute your mic and please provide your brief introduction. So, may I request A.S. Kirthi Naini to please unmute and give your brief introduction. Okay, so if he is not available, then I request the next participant, Shri Dinesh Venkatachalam, to unmute and please give your brief introduction. Next, Dr. J. Rangarajan.
Sir, good morning, sir.
Good morning. Can you unmute your video also, please?
Yes. So I think now you can see me, sir.
Yes, yes, sir. Yes, sir. Welcome to
I'm Dr. J. Rangarajan. I'm working as professor in ECE department, having more than 25 years of experience. Since this is a virtual lab and most of the time as a teaching faculty, so we are concentrated only on theory, conducting theory, but since it is very useful, not only for this pandemic situation, but definitely it will help and motivate our students so that we can able to conduct even lab and we can disseminate whatever the information we gain here to the student community. That is why I am interested. And as you told, already I have joined many courses and got certificate based upon my interest and find that what will be the program conducted by NITTR. It seems to be very good and really useful. So based on my interest, I joined here. So definitely, I will make use of this to the maximum extent possible extent. Thank you, sir.
Okay, sir. Thank you. Thank you. You're So next now I call Mr. Jagdev Kaleka. Sir, are you able to hear me, Mr. Jagdev Kaleka? Yes, Dinesh sir, you are I think now unmuted. So you can please give your brief introduction. If possible, you can switch on your video also. Dinesh sir, you can give your brief introduction now. Neha, can you check there is some problem in unmuting of the participants? Like Jagdev sir has also written that he's not able to unmute himself. Can you unmute?
Sir, the unmute option is with the participants only. It is not with the host.
Okay, so that means participants has to unmute.
Participants on your screen of Google Meet, when you move the cursor at the bottom, the first option is of mic only.
Okay, meantime, I think we can call next participant, Miss Meenakshi Gupta. Can you unmute yourself and give your brief introduction?
Hello.
Yes, ma'am, you are audible.
Myself Meenakshi Gupta. I am from GCT Jammu. I am working as lab supervisor here. That I have no specialization in any field. Thank you, sir.
Okay, thank you, ma'am. You are welcome. The next participant, Miss Pratibha Varghese.
Am I audible, sir?
Yes, ma'am, you are audible. So, if possible, you can also unmute your video.
Is it now visible, sir?
Yes, ma'am, you are visible and audible.
Okay, okay, sir. Actually, I am from Kerala. I'm working as an assistant professor in under the Kerala Technical University in Electronics and Communication Engineering Department. I am as well as I am a PhD scholar also. My interest area is digital image processing. As we have, as due to this COVID pandemic situation, we are conducting the classes in the online mode and labs also in the online mode. So in order to do this lab experiments, I am attending this course in online mode.
Okay.
Especially these digital labs and advanced microcontroller lab. Because I am taking that lab in our college.
Okay. Welcome, ma'am, to the STC.
Thank you, sir.
Shri Raman Chandra Reddy.
Good morning, sir. Am I audible, sir?
Yes, sir. Yes, sir. You are audible as well as visible.
Good morning to all the participants and Balwinder, sir. Myself, I am working as assistant professor at St. Joseph's College of Engineering, Chennai, sir. I'm having more than 12 years of teaching experience. I would like to attend this virtual lab session because of I'm not aware of multisim. Actually, I'm using through online, sir, but I would like to know in depth about the multisim as well as the Tinkercad. So that's what I joined in this session. As well as I attended 3 programs which you conducted by you, sir, which is very helpful for me regarding to my academics as well as the for students also. My area of interest, signal processing and optical communication, sir. Thank you for giving the opportunity to us, sir. Okay.
Welcome, sir. Welcome to the STC.
Thank you.
So next, Miss Richa Jadhav.
Good morning, sir.
Good morning, ma'am. Good morning. So, if possible, you can also unmute.
Yes, sir. Good morning, everybody. I am Dr. Richa Yadav. I am working as assistant professor in Indira Gandhi Delhi Technical University for Women, Delhi. It is first ever technical university in India. And I have more than 10 years of work experience. And my area of specialization in research are digital signal processing and VLSI design, mixed mode signal designs. And I'm really looking forward to these next few days in which I think the fruitful interactions between the experts and participants will immensely help in the academic growth of all of us. So thank you so much, Nita Chandigarh. Thank you so much, course coordinator, sir, for giving me opportunity to attend this FDP. And in these extraordinary times, it is very good initiative for conducting on FDP on such a important topic. Means it is a demand of the hour. We all are requiring these type of platforms, free simulators, because we all are conducting online classes and conducting our lab sessions from home, and all this is going in the online mode from. So it will immensely will be helpful to all the faculty members as well as students. And thank you so much, sir.
Welcome to the STC. Thank you.
If you are getting my voice, I would like to introduce myself.
Yes, sir. Yes, sir. Welcome, sir.
Yes, I am Jagdev Singh Kalekar from Government Polytechnic College for Girls, Patiala. I have 25 years of experience in teaching, and because of the lockdown, as all have mentioned, that it was really difficult to conduct practical classes. So to make students aware of the practical classes and other things which are free to use, I'm joining here, and I will be forwarding these free software materials to students also. Yeah, thank you.
Okay, sir, thank you. Welcome to the STC. Thank you, sir.
Thank you. Thank
you. Next participant, Ms. Tamanna Ansari. So can you unmute the ma'am?
1 minute. Good morning, sir. Can you hear me?
Yes, ma'am. Yes.
I'm Tamanna Ansari, and I work in Government College of Engineering and Technology, Jammu, as lab supervisor. My labs are pulse circuit lab and IoT lab. So this is going to be my first course online, and since we conduct labs offline, so this is going to be very fruitful, so that we can conduct these labs online also. Thank you very much.
Welcome, ma'am. Welcome to the STC.
Thank you.
So I think we could not hear from participants, A.S. Kirti Naini and
good morning, sir.
Good morning, ji.
I am Dr. Dinesh. Can I introduce myself, sir?
Yes, sir. Please, sir.
Yes, sir. So I am Dr. Dinesh from Tamil Nadu. I am working as an associate professor in Kongu Engineering College. My area of research is on antenna designs. I have attended several workshops that is conducted by Balwinder sir. It was very useful. So in this pandemic period, I thought for moving into the online lab classes. So I thought this webinar might give an input to me, so I can able to deliver it to my institution and also to the students. Thank you for arranging such a workshop. Thank you.
Thank you, sir. Thank you, and you are welcome to the STC.
Thank you.
Any other participant? who is able to hear me and has not introduced himself or herself. Okay, so I think with this, now it's time to introduce to you all about our expert of this STC. So this STC shall be conducted by is conducted in collaboration with Touch Techno, New Delhi. And as you might have seen that the almost all the technical sessions shall be taken by Mr. Devender Dhawan. So let me briefly introduce to you all about the expert of the STC. So Mr. Devender Dhawan is presently working as technical manager with the Touch Techno New Delhi, and he has worked earlier as application engineer for more than 3 years with different companies, and he is now part of this Touch Techno from the last 2 years. He is postgraduate in business administration, so he has done his MBA from Amity University. He has done his MSc and BSc in electronics from University of Delhi. He has also qualified UGC NET in 2014. And he is having a strong technical skill in different these simulators, especially National Instruments LabVIEW and this multi-sim software, in addition to various programming languages like C programming or other programming used for the ARM processors and programming using Keel. He's also familiar with Arduino platforms. Recently, we have conducted a very good STC on IoT using LoRaWAN and other technologies. So he is an expert who is doing practical work in different areas of ECE. So he will be taking all the sessions of the course, and I'm sure that this course will be going to be very useful for all the participants, as we are directly taking up various experiments which are being there in the syllabus of ECE lab subjects of polytechnics as well as engineering. So with this brief introduction, now I hand over the session to Mr. Devender Dhawan for his sharing of expertise.
Thank you, sir. Thank you for the introduction. I hope you all can hear me properly.
Yes, you are audible.
Okay, so if anyone is having any doubt in the voice or anything, just let me know in between so that we can rectify it, and then we'll move forward. Okay, so let me just share my screens. 1 second. Okay, so I guess you can see my screen now.
Yes, it is now visible.
Okay, so as we all are aware, like in today's time, we have a lot of issues because of this pandemic situation. There are multiple ways to work around these issues. Okay, but one of the best, cheapest ways what we'll be looking into. So just a brief introduction. Anyway, sir has given these details. Technical manager, and I have some electronics background with me, and experience also in working in all this engineering application and various data acquisition embedded application. IoT and embedded application are something that is really close to me today, and I basically work on these things more often. Okay, so these are some things that we will look in this first session, and in the next session we have some other things planned. Okay, so first we'll try to understand why do we need these online simulators. Okay, why basically now we are going forward with them, why not earlier. And okay, then what all major ECE labs are there, components required. Then we'll look into our online simulator, and we'll try to see how it can help us match our offline labs. Like in offline labs we have a lot of components, and we do practicals. Now how we can try to do something similar, I won't say that exactly similar we'll be able to do, but we'll be able to get a feel of our practical lab, and then we'll be able to understand how these things work even if we don't have any lab equipment with us. Okay, then in the last we'll try to implement Ohm's law and Kirchhoff's law. Okay, So just to get started on the tool, okay, because of these two experiments, you'll understand how easy it is to work on such online simulators. Now, multisim live we have selected because first thing is multisim is pretty famous. I'm sure most of you have already heard about it. And second thing is it is very easy to use. You don't need a specific training just to use it. Okay, even I don't. I also didn't had any training on this tool, so it took me maybe few hours to just get a gist of it. Okay, so I hope the same will be transferred to you all guys also. And during this 5-day training, we'll try to implement all of these labs, not all, the major labs. Okay, then using the same principles, you can try to implement your respective labs also. Okay, uh, then obviously you can make a complete online lab for your particular branch. Okay. So first thing is, why do we need this online simulator? First thing is, we were actually, before even this pandemic started, we were moving toward this remote lab culture, because nowadays many people are working and they want to go for studies. They want to go for studies in let's say universities which are outside their state or outside their country. So these remote labs help us there. Now, remote labs is a concept which basically you can say, like, what will be going to do is online simulator and then the offline lab. So remote lab is somewhere in between those, because you will operate on real hardware only using internet. So remote labs are a bit different. Okay, but yes, this is something that is pushing us toward this online culture also. Okay, so remote labs are required there. So deriving from that only, we have some online simulator which will help us do most of our experiment. Now, the second point is obviously COVID pandemic. We all are well aware about it. I have been working with a lot of engineering colleges pan India, and they all are easily conducting theory classes because that is doable. But everyone is having issue in this practical labs. Okay, so because these components cannot be sent to all of the students. First thing, that they don't have that much of components which are required to send, which you can send to all of these students. Second thing is, they're very expensive also, so that thing is not viable at all. So they have to come up with some idea to basically conduct the labs, because anyway we are losing time and everything because of this pandemic. Somehow we have to make things work. Okay, so that way there are only two ways actually. One is this: you set up a complete remote lab. Now, in remote labs, what happened, that you will be having a setup, okay, a hardware setup, which you will connect to some devices which students can control from his home using internet. Okay, in that case, what would happen, let's say if I'm working on Ohm's law, basic IV characteristic I have to plot. Then what will I do? I will give a power supply, resistance, and I'll put in some voltmeter and current ammeter. Okay, so what I will do, I will add some devices there which will read the voltage from the voltmeter and current from the ammeter. And then there would be one device which will change either the battery with either the input voltage or the resistance, then measure current. Okay, so I will change these parameters. I will give some voltage, record, I will, let's say, increase the resistance, record the voltage and the current, put it in an Excel sheet, again do the same things, and I will get some 10-12 readings, and then I will plot the curve. So that basic IV characteristics. So that in that case you are using a real hardware, okay, but you doing it through online. You can say online things on like internet, or there are various other ways to access the hardware. In that case, that could be one IoT application, you can say. Okay, so that is one thing. Now, if you want to set up such facilities in your lab, that would cost you a lot of money. Okay, so remote labs are not too cheap. They're a bit expensive. Okay, so anyway, with the current condition, we know that finances are also pretty tight across the India, the economy and everything. We are all aware about it. So that is also not possible as of now. So this online simulator is what we can do, which will give a complete feel of a lab, equipments, and how various component works, and all these things students can understand. Okay, and we will be able to conduct all the courses, and we will not lose a lot of time, because it has been almost like 7-8 months we have lost. So yes, so online simulator is what we will use in this case. Okay, then there are like things like online simulator and offline simulator. Okay, so online simulators are a bit different if from the offline simulators. Like, I'm sure you are all aware about multisim. Have you heard about multisim? I'm sure you must have heard or maybe used multisim also. So multisim is actually a spice tool, which basically is an offline simulator, you can say. Okay, you have to download this tool, you have to install it, and then you will use it. So it will work on your system, on your PC. Okay, so that's an offline tool. Now online simulator are different. Like, you don't have to install anything. You don't have to install any software in your system. You will be just logging in into a website using your username and password, and there itself you will run it. Now there are various benefits of this. Like, first thing is, it is a cloud based system. Okay, so you have a higher processing system on the cloud. Okay, so if you are running a very big circuit also in your system, let's say if you're using, let's say, a dual core, or maybe i3 processor, and you're running a very big code, in that case your system might get slow because of various issues. Okay, but in case of cloud, that won't happen, because you're using something very high power at that end. Okay, your system is just a user interface. The actual running is happening at a very high processor system. So that is one benefit. Second is, you don't have to install anything. Every data that you save, every circuit that you make, will be stored online. Okay, now the storing thing is also a benefit in our case. Let's say I have some data, I can store it in my hard disk. Okay, but there is always a chance that my hard disk will let's say crash or stop working. Okay, and I will lose all the data. But that won't be the case if I'm using a cloud. Okay, same things we do with our photos also, or our documents also. Even our emails and everything are online today. Okay, so these things can also be online. Okay, so that is how this online and all offline simulators are different from each other. Okay, so these are some major labs. I would say not all the labs, but some major labs. Okay, uh, out of these labs will be trying to understand this basic electronics lab, where we will see how diode works, like your normal PN diode and Zener diode, how you can make rectifier circuits, this Ohm's law, Kirchhoff's law. These are basic electronics. Then we have advanced electronics lab, where we will move toward our transistors. Okay, then some advanced electronic circuits. Okay, then we have digital electronics, where we have all these gates and everything, and we can make all digital circuits. Op-amp lab is here. Then we have all this comparator and all op-amp circuits, which can be implemented using the tool. Then in last, we will be doing this embedded system labs. So this power electronics and communication will not be doing, but we can do it from our learnings, which we'll get from all these 5 different labs. Okay, so the same concept we can implement on these 2 labs also. Okay, now if we see what all components do we need to conduct a basic lab, is like power supply, multimeter, oscilloscopes, some basic components like resistance, inductance, capacitor, diode, op-amp, transistor. All these things are what we need. Okay, now in a physical lab, in an offline lab, we have all these equipments in our uh, lab. Okay, but in online system, we will have some functions which will act as all these things. So we have all this equipment, we can use all this to build a circuit, then debug a circuit, like we do in a normal offline lab. Okay, So that is what we will be trying to do using these things. So we will have all these different components required. Okay, so the simulator that we are going to use is Multisim Live. Okay, Multisim and Multisim Live are different. As I said, that Multisim is an offline system, and Multisim Live is online online simulator. So let us just move toward this thing, and I would actually like this session to be hands-on, so you guys feel free to just log in into create an ID on Multisim on your systems, and you can also keep on doing these experiments alongside me. Okay, so I would request you all to just open up a browser. Okay, open up the browser and look for Multisim Live on your system. Okay, so Multisim Live first link is what will be opening. Okay, so you will land on this particular page, and there are some features, pricing, circuits, resources. I'm logged in, so let me just log out once, and we'll see from the starting. Okay, so this is how it looks like. So now I already have my account, so I will log in, but I will show you how you can sign up. So you keep on, you also keep this at your end. So here you have to give some ID, like mine is Devinder_TT, first name, last name, and role in your organization. Okay, then your organization name, company address, city, postal code, and all, email, and then you put in an address, and then you create an account. It is as simple as that. So it will send an email for confirmation, and once you confirm, you will have your account working. Okay, so I will anyway just log in here. Okay, so my email is this, and my password I will add. Now I'll just log in. Okay, so you can see I've logged in, and I have one circuit here which I made yesterday itself, which is a full wave rectifier. I'll show you this in the next session. So I'll give you a minute. You please create your account quickly. You all please create your account. Okay, let me know if you're having any issues in this, and then we will rectify it, and then we'll move forward. So if you're having any issue, you can share your screen, and I'll also help you out. Okay, so I guess you all have made your account. If there are any problems, let me know. Otherwise, I'll move forward now. So we can just when we open this particular tool.
Excuse
Hello,
me, sir.
sir. I'm
Yes,
not
ma'am.
able to do the.
Yeah,
Hello.
tell us, ma'am. Tell us.
Hello, sir. I'm Tamanna Ansari. Sir, you are saying to create an account. I'm noting down the steps, but since my internet is not that so fast, so I'll
No problem. In
make
that case,
an
you can just
after
no
the
problem.
session. If I have any problem, I'll contact you.
Sure, no problem. That can be done.
Thank you,
Okay.
sir.
Yeah, there was someone else also having some query.
Sir, myself, sir, Pradibha. I am not able to
Yes.
create the account, sir.
Ma'am, you can let me know what issue you're having.
Sir, I'll share screen and show you, sir.
Yeah, sure. See, share screen and show me.
For sharing the screen by the participants, I think during this you need to stop
Okay,
in.
stop presenting. Okay.
So can you see my screen, sir?
Yes, we can. Okay. Add some password. The email you entered is already. One second. Not able. Okay. Already on file. So I guess the email that you're using is already registered with NI. So you don't have to make an account. You have to log in there. You should have. You would have actually registered on ni.com earlier. So you have to log in there. If you remember your password, it's okay. Otherwise, you have to get it. You have to go under forgot password.
Sir, I had to join again, sir.
No, just go back. Log in. Just log in. Go up. Yeah, log in.
Here, sir.
No. Go up. This login you see na under this already have an account login. Create an NI user account. This here you go. Okay. Now you log in. Put your password here. If you don't remember it, you can forward password and retrieve it. You please go to forward password and you can retrieve it from there. So you already the issue that you are getting is because you already had registered your email address here. So that is why it was giving you that issue. Otherwise, there was no issue.
Sir, can I log in from a different account, sir?
Yeah. If you have a different mail ID, you can just create another account. You see? Okay, so you have made your account. So
Yes.
this is okay. You can stop sharing now, man. I'll start. Okay, so now hope you can see my screen. So this is what you will see on the first page. Like here you can see the number of circuits you have. Like I have one only right now. Okay, then your favorite circuits if you have any, or if you have joined any group. So one good thing about this is that there's a big community of people who is already working on Multisim Live, and they have already made multiple circuits for you to use. Okay, and they have multiple groups where you can put in your questions or doubts about circuit or the functionality of the tool and everything. So this is something you can look at. Okay, so I have only one circuit, which is this one right now, which I will show you later on. But right now, let us go into the features and see what all things are there. Okay, so first thing is that expanding the multisim experience. Like multisim, I told it is an offline simulator, and here it is also written for desktop only. So now you don't have to install anything. You can just work on any browser. Okay, the second good thing about online simulator, which I missed earlier, is that it is not specific for any particular OS. Like most of the time, many companies launches their product for, let's say, Windows or Linux or Apple only. uh, Now the famous tools come out for all the OS, but not all the tools. So that restriction is removed from working on online simulator, because it doesn't matter which OS I'm using. I have to log in using a browser here, so it's okay. Okay. Now interactive circuit simulation, because we will see all the waveforms and everything. That is why it is interactive, and with no installation. Okay, that is one point. Okay, same industry standard spice simulation is what we will be doing here. So you can be rest assured that the model that we are going to use are spice model only, not something like that only. Okay, share your circuit brilliance with the community. Okay, like I said, there is a huge community of people here. Okay, so you can share with them, and if you're having any problems, you can share with all of them, and they can help you out in circuits and everything. Okay, so complete circuit teaching solution. That is what actually we are going to do here. Okay, we'll try to understand all the circuit needs and how we can implement different circuits for different lab. Okay, and how we can get it going on into our syllabus. Okay. Some new features are there. Then streaming circuit simulation to measurement live. Okay, this thing we will leave because we'll not be going to this work. Okay, so this was about the features of the tool. Now tutorial also we have here. Okay, so how to create a design, simulator design, streaming data, schematic, simulation components, shortcuts, all things are here. So let me just give this particular link to all of you so that you can also look at it later on. Okay, so but anyway, we'll be understanding all the working by a circuit itself. Okay, so let me just create one circuit. Okay, and that would be we'll try to implement the ohms. Okay, so this is my first front page. You see this create circuit here. I will click over it. Okay, so it will initialize multisim live, and this is my schematic, or this is my bed. Okay, so if you see on this left hand side here, there are some components listed here which we can select. Okay, then there is like if this particular circuit is public circuit or private circuit. Private we cannot make because we are using a free account, so only prime account members can have a private circuit. So whatever we make here, we'll okay, so you can name the circuit here, put some description, add some tags for people to search it. Okay, like it could be rectifier, circuit, or full wave rectifier, half wave rectifier, or it could be any other tag that you want. Okay, so we will not do that right anyway. So if let's say I'm measuring some waveforms, I can go under this graph here, and my data will come here. So anyway, right now there's nothing, so I will not see anything, and I can just go on split screen, where I will see my circuit here and my waveforms. Okay, so let me just go on to schematic. Then we will see what all things are here. Okay, so let us go first this one. So this is analysis and annotation. So analysis, obviously we need probes. Analysis means we are going to debug our circuit, and we are going to see what all results are coming. So for that, in normal circuits, in normal labs, what we do, we have a DSO. Then we use probes, and we connect the probe on our circuit point and the ground, and then we measure the waveform, and that is what this. So our DSO is going to be this graph, okay, where we will see our waveforms, okay, and our probes will be this. Like if I'm measuring a voltage, So I'll use this voltage probe or a current probe separately. Then there is a combined probe which will do both tasks. Okay. Then for digital, we also have a probe which will show us 0 or 1, basically true or false, because that is what digital signal will be. Annotation is basically a text to mark something, like just to tell, okay, this wire is for this particular purpose, this probe is for this particular purpose. That is what this is, just a text. Okay. Then there is a voltage reference. Now, how to use this voltage reference, that I'll tell you later on. Okay. Then under supplies, if you go, we have AC voltage, DC voltage, FM current, chip voltage, DC current, AC current. All these things are there. Okay. So there are various sources are there, like square wave, triangular wave, triangular current is there, step voltage, step current, AM voltage, FM voltage. All these things are there. The noise is also there. So we'll basically be sticking to these two, like DC voltage and DC current. Sorry, DC voltage and AC voltage. Sometime we might use AC current and DC current. So we'll stick to these four basically. But for any of your application, you can use any of these. Okay. Then if you go in next, we have resistors, capacitor, inductor, potentiometer, fuse. Then transformers are also there. Now in transformer also we have one primary, one secondary, one primary, two secondary. Then we have one primary with center tap also. Okay, so this you can use. Then we have coupled inductor. Then we have resistors also. Okay, voltage controlled resistor or impedance block. So these are also. Then here we have 3-terminal op amp, 5-terminal op amp, ideal comparator, 555 timer is also there. Then we have spice model of these two also. Like the model that we are seeing here are generic op amp. Okay, so these are generic spice model for op amp, but these are for specific ICs. So in free version, you don't get all the spice model of all the ICs. Like UA741 or LM324 are also op amp ICs. So you get these two in free edition, but not the other ICs. If you want that, obviously you'll have to go for a prime account. But for our application, the generic op amp will be good enough. Then we have diodes, Xena diode, LED. Then we have this particular spice model, also, this part number. Okay, so we'll anyway we will be sticking to these models also. Then NPN, NPN, PNP, and all this transistors are also there, and specific part numbers are also there, okay, that you can use. For PNP also we have a specific part number. Then NMOS also we have a specific part number that we can use in our experiments. We have lamps, LEDs, 8-bar LEDs, buzzers are also there, switches are also there. Okay. Then we have modeling blocks, which we will not be using anyway in our lab right now, but later on you can explore all these things. Now electromechanical things are there, like relays are there. Okay. Combination in relays, normally open relay, normally closed relay, motion controllers, and all these are like DC machine, permanent magnets. These can also be used into your electrical labs. Then we have power regulators. Okay, LM317 also is here. And in digital, we have all the gates, then buffer, inverter, XNOR, and digital constant also. Okay. So you see under AND we have 2 input, 3 input, 8 input, 5 input. Okay. So these things are there. So we have a pretty good enough library which we can use in our experimentation. Okay, so let us just start with a basic Ohm's law. Okay, we are anyway running out of time, so we'll quickly do the Ohm's law, and then in the next we will start with the Kirchhoff law. Next session, which is on 12. Okay. So I will go under passive components. I will single click on resistance. So you see, this resistance is there with me now on the cursor. Let me just place it here. Okay. So it is a 1K resistance. I can just click over 1K. And I can add any value here, let's say 1 mega, okay, or anything that I want. Now, second thing I need is a power supply. So I will go under power supply and I will take a DC voltage supply. Okay. So this I will place here. Okay. So this is right now 5 volt. Okay, let's say make it 10 volts. Okay. Then I need to connect it. Let me just. So how do you connect it? Like you can see that my cursor is in shape of hand. So it basically is to grab and move things around here. Okay. But if I put my cursor on this terminal here, you see that it is changed. It is a wiring tool. We call it a wiring tool. So I just single click now. Okay. And then if I move, you can see there's a wire. Okay. So let me take it to the end I want to connect it. And then once this happens, I will single click. So my wire is complete. Okay. Now the next thing, again, I will disconnect this and bring it back here. Okay, and single click again. So my circuit is complete. I have one battery. I have one resistance. Okay. Now what I need? I need some probes to analyze my data. Okay. So I need to monitor two things. One is voltage. Okay. Uh, Voltage. Then another is current. Okay. So current will be anyway. There's only one wire, so current will be same throughout the circuit. But voltage I want to measure across this particular resistance, not the complete voltage. Okay. So the voltage drop across this resistance. Now the probe that I use here will measure my voltage from this point to the ground. You can see voltage reference. Okay. So if I double click on this, this particular probe will come up and it will show me that it is measuring with reference to ground, which I don't want. I want to measure between this point and this point across this resistance. Okay, so let me just go on this our probes again, and this voltage reference is what we use. Let me click it. So if I place it over the wire, you see this circle will start appearing. I will single click now. Okay, so this is reference one. So if I now go under my probe here again, double click on it, you see voltage reference with ground or reference one. Okay, so now I want to use reference one. So now it will give me voltage drop across this resistance, not between this point and the ground. Okay. So with the ground, we obviously have to give in a ground here. The ground is here. Okay. So you can just click and put it. So now let me just start. Okay. So this particular button will start the simulation, and you can see right now the voltage drop is minus 10 volts because there's no what you can say. No other resistance here. So that is why all the voltage drop is across this resistance only. Okay. So let me just change this voltage. So you can see the voltage and current both are changing. Okay. So let me just fix it on, let's say, 5 volt. Okay. So what I will do now, I will change this. Let me do one more thing. Let me add another resistance so that we have uh, a better result. So I will connect this one to this one. My probe will, my voltage measurement is again against this only across this particular resistance. Okay, so we can do the same thing around the other one also, but we will be doing it here. Okay, so now my current will also be same here only. Okay, so now if I run this, you see the voltage drop across this is not 5 volt. Okay, because we have another resistance now. So if I change my resistance value, you see the drop, the voltage changes. So let me just put one more voltage probe. Okay, so and one more reference point. Now this would be voltage reference number 2, and this particular one we will measure. You can see reference 2. Now we are measuring between this particular across this particular intervals. This particular. So now if I run it, you can see 4.3 volt and then 0.66 volt. So combinedly it makes 5 volt, which is what we get. Okay. So now what we can do, Let me just open Excel. Okay, so what I will do, I will try to give one particular voltage. Okay, then I will measure the current. Okay, and I will plot the IV curve. Okay, so IV curve, I will just do it across this. Basically, let me just give it 0, let's say 0.5 volt. Let me do it. Okay, so you can see the current is 0.66 sorry, 66 micro, or I can say 0.5 volt, it is 0.00, sorry, 0.66 millivolt. Okay, so I'll milliampere, sorry. So I'll put in milliamps here. So I'll put current in milliamps here, and then I will put my voltage here in volts. Okay, so let me just go back to my simulator again. Use it to 1 volt, and then my current is 0.133. Okay, so for 1 volt we have 0.133. Let me make it 1.5. We have 200 microampere current. So 1.5 is 0.2. Then let me go back and let's say 2 volts. We have 2.66. 266. So for 2 volts we have 0.266. I'm just quickly making a small IV curve. So for 2.5 we have 333. 0.5 we have 0.333. Then we give it 3 volts here, and we have 400 microampere. We have 0.4, and we'll do till 4. 3.5, we have 466. 0.5, we have 0.466, and let's give it 4, and we have 533. 4, we have 5.5. So this is the plot. Let me just plot it. We can actually have multiple readings, but we get this one. You see, we have our current into this, so it is a linear waveform, which is what we expect from a normal IV characteristic, which is what our Ohm's law state. So we can now try and measure the slope, and we will get our resistance. Okay, so that we can do. Okay, so I hope this is clear up till now. If you have any doubt, please let me know. Even if you want to see the graph, because you see we are measuring 2 voltages, so you can see these voltages are keep on running here. Okay, so you can see that the voltage drop across is minus 3.466, which is this one, and this one is let me just tell you 533 millivolts, which is this one, and it is keep on running now. So graph part also we'll see later on, but this is what our Ohm's law states.
Sir, I have a doubt, sir.
If you have any doubts, please let me know.
So how do you open the one more screen? One more screen you have opened. You track this screen. How it is opened?
Sir, either you can go to the graph, or you can go to the split, which will show you both schematic and your graph.
Okay, okay. Thank you. Thank you. So what we got to open the Excel sheet separately.
Yes, sir. So
Okay,
Excel
okay.
sheet I opened. Like in normal labs we do, na, so like when I'm working on this IV characteristic, I will increase the voltage, measure the current, increase the voltage, measure the current, write it down in a table, then I will plot it on my on a graph or maybe an Excel sheet.
Okay.
So the same way I am just trying to replicate the same process here also.
But no. So I have doubt that whether it is possible to open Excel sheet in that also, in that software also available. That's why I'm asking.
No, there it is not possible.
Okay.
So anyway, we have to use this one only. Okay. So we can measure this here, or we can plot a running waveform here. But if you want to do this analysis, then you have to put on data on this Excel sheet. Okay, so that we can do. If you have any doubts, please let me know. Any
Sir?
other doubts?
Hello, sir. Hello.
Yeah, tell me, sir.
Sir, could you explain once again how to keep the reference, those things? Sir?
Okay, so reference, let me just show you, sir.
Okay.
Let's stop it first. So our issue was that we wanted to measure voltage across this resistance. Okay. Now the probe that I use, like normal probe, let's say if I take this voltage probe, so this voltage probe, wherever I put, like let's say this point, so it will measure the voltage between this particular point and ground. Okay, so which is normally okay, like that is what normally we do in our labs. We measure a signal in reference to the ground, but in this case we are measuring voltage across this resistance, not at this point and the ground. If I measure between this point and the ground, it would be something else. Okay, so what I do, I put in a reference here. Like if I go under here, I put in a reference like this one here. Okay, so now this is a voltage reference. Okay, so now voltage references are used for this purpose only. Like if I double click on this one here, so you see this window will come up and it is showing me voltage reference. Now I can there are two reference in my circuit, like this one is another reference, this one like voltage reference 2, voltage reference 1, and the ground. There are three references that we can use. Okay, so out of these three I can choose any, either ground, reference 1 or reference 2. So in my case I wanted reference 1 because I'm measuring across this. Okay, so whatever voltage I'm getting before this part is eliminated, and I will get this part only. Okay, so that is what we were trying to do. So that is how we use references. So we'll anyway keep on using this, so with time you'll understand it in a better way.
Thank you, sir. Thank you.
Okay, if there are no more doubts, we can stop for this session. The next session would be from 12. Okay.
So what time we have to join? 12.
Yeah, I guess. Yes, sir. You have to again. We'll break for 45 minutes now.
Excuse me, sir.
Yes, ma'am.
That current reference where it is taken, sir?
Current reference?
Like after the 1 kilo ohm, we have PR3 where it is taken, sir?
PR3 is your voltage, ma'am. This is voltage reference.
Other one PR2?
PR2 is for emitter, for current. This is against here only. If you click here, you see voltage, current. We actually have this also, which is a single probe which will measure both voltage and current.
So here which is placed
current,
is PR2?
Current.
Okay.
So whenever you are working with current, you have to place this current. And you can see, like for voltage probe will show you V, and current probe will show you A here. You can see written in this.
Only after running we will see the values, sir?
Exactly, ma'am. Right now, because these probes has been executed once, so they have some last value. But right now, this probe hasn't run on once, so it is not showing any value. If I run this, you see now it is showing some value, or because both of these are serial, and in serial current is always same. We know all that. We all know that. So that is why the values are same here. Okay. Now if I stop it, it will remain same because it will show you the last value it read. Now if I put another probe, it will show nothing because it has not measured anything as of now. Okay, so that is how these things work. So last value that it read will be shown here. Okay, any doubts, ma'am?
No, sir.
Okay, so ma'am, we'll stop now. I guess there is someone from Knitter side.
Yes, sir.
Ma'am, we can stop for first session here, and we'll start at 12 for the next session.
Right, sir. Right, sir. To all the participants, I'm sending a link of attendance for this particular session. Please mark your attendance, and we'll be joining back at 11:55. We'll start the session at 12. Thank you,
Sure.
sir.
Thank you, ma'am.
Thank you, sir.